Okay. So basically, why set is important in our topic? I already mentioned that maybe last class or the previous class that when we are going to design a machine, let's say our machine or our automata will accept only those strings that are in suite A. That means the machine can accept a set of language. So what is it called? It language, right? So when your machine can accept a certain strings that can be infinite strings at the same time. So total set of strings is called language. So that's why the idea of set is very important here. So we will see the applications later on. Our next one is uh, elements of set. So elements of set means the members of that set or the objects in their set, right? Then one of the important idea is subset. So what is subset called? So set A is subset of set B. So it means if every members of A also is a member of B. So set A is a subset of set B if every member of A is also found in B. So this basically includes possibility that the two sets are identical. So let's say if B sets having, let's say, 1 2 3, right? So if B sets having 1 2 3 and A sets having 1 2, so we can call it's a is a subset. Even B is also subset of its. So it's a very basic idea. I think you got this. So I mean the element of A, if the element of A also present in element of in the B sets. Now let's talk about the proper subset. What is mean the proper subset? So set A is subset of set B. That means A subset of B. And if A is subset of B and not equal to B. So if A is subset of B and not equal to B. So let's give an example here. So a proper subset is a strict version, so far I understand. So A must be a subset of B, but it cannot be equal to B. There must be at least one element in B that is not in A. So let's say I'm giving the same example. If B equals to 1, 2, and 3, then A equals to 1 and 2. So this is called a proper subset. I mean, the last example I have given, that is exactly the example of the proper subset, okay? Where elements of B will not be the equal of A. And last point is here, that is called the infinite set. So infinite set means that the set which contains infinitely many elements. So, while the examples, uh, I mean, previous examples, what you've taken, let's say 1, 2, 3, these are quite finite, right? But an infinite set, of course, goes for forever, right? So the set of, let's say, the set of all even numbers, isn't it? So no matter how long we count it, but we will never reach the end. That is the infinite set. And already I also mentioned that our machine will accept all the strings that will end with A. And here, these examples also implies that our machine is going to accept an infinite number of set. Okay, so I think these are the basic idea. Then our another point that is called empty set. So empty set is a set with zero members and is written as phi or uri. The empty set is exactly what it sounds like, a set containing nothing. So just you can think of it like an empty box, and it's a subset of every other set. So the notion, I think you got the notations. Basically, we are familiar with this, that phi or uri, there is a thing. Yeah, so our then we have power set. I think you all must know this power set, and these two topics like power set and Cartesian products are important for your exam at the same time. So for any set A, the set of all subsets of A expressed as 2 to the power A. If A has n elements, then 2 to the power A has 2 to the power n elements. Phi and A are also elements of the power sets. So the power set is basically a set of sets. And of course, it's a collection of every possible subset. You can create from the original set and including the empty set and the set itself, right? So if our element is 2, that means total power set elements will be 4, right? 2 to the power 2. And of course, phi or uri or the empty set and the itself that set is the elements of that and all subset list. So remember that the set of all subset is must. Then we have Cartesian product of A and B, and A and B is the set of all ordered pairs where A belongs to set A and B belongs to set B. So ordered means that the pair A comma B is different from the pair B comma A. I think you got this point. So if A has an elements, so if A has n elements and B has m elements, then the set A Cartesian product B has exactly n into m elements. So let's say there is an example. If a equals to 1 comma 2 and b equals to x and y, so Cartesian products will be 1 into x, 1 into y, 2 into x, and 2 into y. I think it's difficult, if it is possible, if I can actually use the board and marker, then it's actually easy to get the idea. Maybe in the class, if possible, I will repeat these types of session. But if you cooperate, I think this is enough for us, because just we are actually getting the idea. Now let's try to understand the description of sets. Let's say specify a finite set as a list of all elements of a set, right? This is one of way possible, because we here specifying, here we are specifying the elements of the set. That means it is very easy to get the idea what the set is about, right? So very simple number 11, 12, 13. So this is one way that how we can actually describe a set. So specify a finite set as a list of all elements of a set. This is the most easy one even. But number two, Meher, Anwar, Jessia, could you please
আমাদের এখান দোকানে যে কাঠের আঠা কিনে তারপরে আম্মুর কাছে যেতে হবে, তাই আম্মুকে পেতে হলে আগে একটা
Okay, so come back to the point. So this topic is very important, the slide I'm sharing with you. So that means when we are actually describing a set, if the set itself described like the number one, that is very easy. But the most hardest one is you need to apply some logics. You need to think of it. Let's say specify a finite set by assigning a property that characterize the elements. So this one is the quietly hardest one to guess. So remember, in your exam, it will be always you will get the set based on, you'll always get the set based on number 2, or like the number 2. So here example, b equals to x, as if x is an odd integer greater than 1. X is an odd integer greater than 1. So this is kind of example, right? This is kind of example. So x is an odd integer greater than 1. So can anyone help me to construct this set? Anyone?
So like uh, 3, 5, 7, dot, dot, dot.
Yeah, that's great. Okay. So me remember, in our every problem will be something like this, uh, with some definitions that we need to understand the definitions, and we need to actually form. So this is the step. This makes your steps more harder, right? So when you are going to describe a set like this way, you need to construct the set first, then you need to draw the machine for that, for accepting their set. So one of our tasks is something like that. We need to construct the set, at the same time we need to design the machine. Then we need to design the machine that is accepted. That is accepted by this machine. So the entire set need to be accepted. So complement of a set. So A is the set. I mean, A is a set A prime of everything that is not element of A. So there is a notation here. I think you got this, that A prime means all the element that belongs to that is represented by X is belong to U means the universal set. So U is a universal set containing all elements under the discussion. Or X not belongs to A. That means complement of set A means all the elements of universal set, but not the elements that actually present in A. That means except A elements, all elements is the member of the complement of a set. So union of sets means that A and B is the set A union B. So X as if X belongs to A or X belongs to B. So that means we are actually combining our all A and B and making a set. So common and uncommon all will be the members of this A union B. And if we talk about the intersection of sets, A and B is the set A intersection B. That means X belongs to A and X belongs to B. That means in intersection set, we always take the what? Common. Only the things common in set A and at the same time set B, we actually choose them. They are the member of intersections of set. Then what is the set difference? So set difference is basically set difference is the set of everything in A but not in B. So we are going to eliminate all elements from the B. Okay, even those are common in with A, that will be also eliminated. So B we are not actually taking any elements from the B. Rather, if any elements in A that that actually presents in set B, we are not also going to take them. This is the set difference. So no worry, I think I will give you a homework when we will be in the class, so that everyone have the idea, a better idea to recall every points. Okay, so let's talk about the disjoint set. So disjoint sets means A and B are disjoint. That means have no common elements is there, right? That means if I draw a set like this is one set and this is another set. So there is no common terminology with this. And last one is the symmetric difference. A symmetric B of two sets are defined as A but B union B but A. So this is means that actually when our two set actually intersect in such a point, so when we are keeping the common one intersection, but this means A but B, this part, and also this open part. I think it's something like that. So let's say this one set, and this one is another set, and we know this is the intersection part, right? But this one is actually called the A bar B. I'm not good at drawing. And this one, as I'm not using also mouse, also that's a problem. This one is called A bar B. So the union of this result is called actually the symmetric difference. Okay. Yeah. Okay. So let's go one of the idea that maybe you have covered in discrete mathematics. Just to recall them as mathematical notations. So here, first one is the proposition. What do we understand by the proposition? So proposition is a declarative statement that actually declares fact and that have a true value. So I mean truth value, actually not true value, truth value. So it can be true or false. So proposition is a declarative statement that declares a fact that have a truth value. It can be true or false. That means it have a value. And let's say there is example here. So there is example here that I am 30 years old. So I'm 30 years old. This is true. This can be true. So I always tell the truth. This can be true. But at the same time, when if it's repeating that I'm 70 years old, this must be false. So that means every statement that have a truth value, either it is true or it is false. Then one another point that is called compound proposition. So compound proposition means a compound proposition is formed from simpler proposition using a logical connective. So what are those logical connectives? That is, let's say tautology. Tautology is a compound proposition which is true in every case. So that is called the tautology. And if we talk about the contradiction, then contradiction is a compound proposition which is false in every case. So tautology true in every case, contradiction false in every case. So you will see the application or the uses in there. But let's got to understand that let's come to a point called Boolean logic. So Boolean logic is a mathematical system built around the two values, true and false, called as Boolean values. So Boolean logic is a mathematical system built around two values, true and false, called Boolean values. So there is example of logical connectives. So in logic, these terms describe the connectives used to join simple statements into more complex ones. So basically, how we are going to we are going to form a logic when we have more complex sentences, more complex operations, so more complex statements. So this is the basic building blocks how we actually write the logic. So we can also think them as a mathematical operators. But these mathematical operators for sentence, not for the, I mean, numbers. So first one is the negation. I think you know that negation means that's just using the not, right? So I'm telling that today is Friday. So we can say that just today is not Friday, right? This is one of the example. But let's talk about the conjunction, and that means basically and. Uses means that basically and, right? So a conjunction is true only if both statements are true, right? And we know this and actually works in the same way. So a conjunction is true only if both statements are true. So if even one part is false, the whole thing is false, right? So to become true, both statements need to be true. But if even one part is false, then whole things is false. So the symbol we are using here, this is also we can read as and. So one of the example I can give that, let's say the sun is out and it is warm. So the sun is out and it is warm. So what is the logic behind this sentence? Let's say if the sun is out but it actually freezing, the entire statement is considered false, right? So, but if the sun is out but it's warm, so logically it makes sense that okay, fine, it's the correct one. So same goes for the disjunction. Disjunction mean or. So a disjunction is true if at least one of the statement is true in logic, or usually includes the possibility of both being true. So these symbols is also we read as or. So one of the example that is that, let's say I will eat pizza or I will eat pasta. Right, so this is true if you eat pizza, I mean true if you eat pasta, and also true if you eat both. So this actually the meaning of disjunction, that if one of the part is true, then you can consider the both statement as true. Our next point is conditional. So conditional means, just few seconds. Okay, so I'm back. So we are discussing the conditional. So conditional connectives means it's quite if-then relation, right? If there is P, then Q will be there. So Q is depending on P, right? So a conditional statements basically suggest we can determine it as a cause and effect relationship, right? Cause, this is the cause and this is the effect. Cause and effect relationship. So it is only false if the first part, the if happens, but the second part then fails to happen. So it is only false if the first part if happens, but the second part, the then, fails to happen. So basically we read this symbol, let's say P implies Q. So one common example of conditional that if it rains, then the ground will be wet. If it rains, then the ground will be wet. That means when this statement will be false, when the first part if it is not raining, and but the second part that then the ground is dry, then the entire statement is what? False. So if it rains and the ground stays bone dry, the statement was a lie, right? So only in that case it is false. So there is a truth table in the next one. Let's for the conditional statements. So you can actually check every sentence if you actually put the value of these, right? And also we have the biconditional example. So biconditional means here actually it's called the only if. So if and only if. So P only if Q and P if Q, or P if and only if Q. So this is called the biconditional. So it is actually two-way street. So it is true only when both statements have the truth value. Either both are true or both are false. So let's say a polygon is a triangle. A polygon is a triangle if and only if it has exactly three sides. So logic that if it has three sides, then it's a triangle. If it is a triangle, it has three sides, so they are perfectly locked together, right? So these are the basically the example, and you can actually check every sentence by yourself with these truth tables of these propositions, so to get the better idea regarding this. So our next topic is function. So I'm not going to start function. So next class I will discuss the function. I think here basically we have discussed a lots of topic regarding set. We are recalling the set, also description of the set, of some basic operation regarding set. So and I also mentioned the important topics when we are discussing. Then we come back to the propositions, compound propositions. So to understand the compound proposition, basically we got these logical connectives, and Here is the truth table also regarding the proposition. So we will discuss the function from the next class. So yeah, we are done for today. If meanwhile, if you have any question regarding any topic, you can ask. Response please, Ashikur Rahman. Meanwhile, you submit your class summary in the WhatsApp group with your ID. Serial number 2, Nazmul Hassan Ashik. Meherun Nessa Choiti.
Present, sir.
সৌরভ চন্দ্র দে,
Present, sir.
নাবিল সিদ্দিকী,
Yes, sir.
নিলয় দেবনাথ, তাসনিম আক্তার মাওয়া,
Yes, sir.
মাহফুজা ইয়াসমিন,
Yes, sir.
মিমমনি,
Yes, sir.
এহতেসাম শরীফ,
Yes, sir.
নিশাত তাসনিম, বরুণ কবির,
Yes, sir.
সাজিদ,
Yes, sir. Niloy Devnas, 3L6.
সাজিদ,
Yes, sir.
মাইনুল ইসলাম,
Present, sir.
শুভ, ইয়াসিন
Yes, sir. Yes, sir.
সঞ্জিদা আক্তার,
Yes, sir.
হালিমা খাতুন মিম,
Yes, sir.
সুমাইয়া মিম,
Yes, sir.
সামি আফরিন,
Present, sir.
মেহেদি জামান জাবের,
Yes, sir.
ফারিয়া বিনতে,
Present, sir.
নিরূপেন চাকমা,
Yes, sir.
মাশরাফি আল মারুফ,
Yes, sir.
মাহবুব আলম মাসুম,
Yes, sir.
হৃদয় মালিথা,
Yes, sir.
নাজমুল ইসলাম,
Yes, sir.
সূচনা খান,
Yes, sir.
রাফি ওয়াহিদ, নিলয় বিশ্বাস,
Yes, sir.
তৌহিদা আক্তার,
Present, sir.
নওরিন আজাদ রুহি,
Yes, sir.
Sir, Rafi Wahid, serial 28.
ফারিয়া আহমেদ,
Yes, sir.
সাদিয়া ইসলাম,
Present, sir.
তানিয়া আক্তার,
Yes, sir.
রিজাউল করিম,
Yes, sir.
সারোয়ার জাহান,
Present, sir.
মাহিমা আক্তার,
Yes, sir.
রায়হানাতুল জান্নাত,
Present, sir.
আহসান হাবিব,
Yes, sir.
মাহের আনোয়ার,
Present, sir.
Jessica, next time
Present, sir.
you should be careful when you are joining the class. in the middle of the class, your microphone was, I mean,
Yes,
unmute.
sir.
So
Yes, sir.
next
Sorry,
time you
sir.
should be careful regarding that.
Okay, sir. Sure.
Humaira Alam,
Sir, present, sir.
Proma Bishwas,
Yes, sir.
Fahim Shahriar,
Yes, sir.
Shojibul Haq Shojib,
Yes, sir.
Pushpita Shikdar Dola.
Present, sir.
Okay, so we are done for today. Here, please, by 12:50, you will actually inbox me. And remember, this will be considered as a class test number. Okay, thank you everyone. See you in the next class. Allah Hafiz.